Hi, I'm Coach Cowland, and in this presentation we're going to look at projectiles. So first of all, what do you think the definition of a projectile is? Give some examples of what you think. Pause the video and then move on when you're ready. The definition of a projectile is an object that has a horizontal velocity that is greater than zero and is only accelerated by the force of gravity. An example of a projectile could be a bullet after it leaves the barrel of a gun, a ball that has been thrown or kicked, an object that has been dropped from a moving aircraft. This is because the motion of the aircraft gives it the horizontal velocity. A BMX and rider after it's left a stunt ramp. These are all examples of projectiles, and there are many more. Projectile motion is a form of two-dimensional kinematics, and because of that, we need to do all of our calculations in each dimension separately. As our vectors are split into x and y dimensions, we have an x and y component for initial velocity, final velocity, acceleration, and displacement. Time is dimension independent, which means that we can use the same value of time for time whether we are calculating x values or y values. First, let's look at acceleration. We know that the only acceleration is gravity, and that gravity acts downwards. This means that there isn't any kind of horizontal acceleration. If we first look at this in the vertical, we'll see that the final velocity Vy is always going to be less than the initial velocity u of y because acceleration is negative. However, in the x dimension, because acceleration is 0, the final velocity v of x is simply equal to u of x. This means that our initial horizontal velocity component is our final horizontal velocity component at any time during the projectile motion. This is an important fact that will help us during our calculations. For a horizontally launched projectile, the initial velocity in the x is the final velocity in the x, and the initial velocity in the y is equal to 0. As we said before, the horizontal final velocity is equal to the horizontal initial velocity. However, the vertical final velocity is always going to be less than 0. In projectile motion, it's important to define which direction is positive and which direction is negative in the x and y dimensions. The easiest way to do this is to define the upwards direction and the forward motion of the ball as the positive directions. When we do kinematics using projectile motion, we use all of the same variables and we can find all of the same variables as we do in one dimension. However, we must remember to keep horizontal and vertical calculations separate. Here's a question for you. Which would land first, a dropped ball or a ball thrown horizontally from the same height? Pause the video, think of your answer, and then hit play when you're ready. Because the only acceleration is gravity, and gravity affects both balls equally, both will land at the same time. The horizontal motion of the ball has no effect on the rate at which the ball falls. Let's do a sample problem. A projectile is launched horizontally at 1.2 meters per second. It travels a horizontal distance of 0.5 meters. If acceleration due to gravity is negative 9.81 meters per second squared, what is its final vertical displacement? First, I identify my data. Next, I list my variables. When I list my variables, I need to be careful to list variables in the x dimension and variables in the y dimension separately. For this problem, the easiest way to solve it is to find out how long it took to fall and then use that time to find out how far it fell. Drawing my diagram, I can see all of my variables clearly. First I find how long it took to fall. The easiest equation for this is s equals ut plus 1/2 at squared. Because I know acceleration in the x is equal to 0, this simplifies to s is equal to ut. Solving for t, I find the time is equal to 0.4166667 seconds. In order to maintain my accuracy, I don't want to reduce to two significant figures just yet. Now I have my value for time, I can substitute in to find my vertical displacement. I know that my initial velocity in the vertical is equal to 0, so s of y becomes 1/2 at squared. Substituting in my value for t, I get an s of y of negative 0.85 meters. This means that the height of the object is 0.85 meters below where it started.